The Bridgeport mill is a big machine that you can't miss. Its big, heavy design and all its metal and knobs and levers makes it one of the first things your eye goes to in the lab. I'm here to show you today how to use it. Today, start with basic operation. Step 1. Turning the machine on. On the back of the Bridgeport, there is a circuit breaker. Make sure that it is in the up position, like it is here, so the machine can work. Step 2 is the lighting. In the upper left here, there is a lamp. To turn on the lamp, there is this lever here. And you have ample lighting to do work on small pieces. Now, to start powering the spindle, we have to move on to step 4. To complete step 4, which is powering the spindle, you have to use this lever up here, or this knob up here. In the middle position, the spindle is not moving. In the upper position, it moves in one direction. If we turn it, and if we put it in the lower position, it rotates in the opposite direction. Next is step 5, changing speeds. To change speeds, we need to have the machine running. So we'll turn it on. To change speeds, you spin this handle here, either up or down, to lower or increase the speed. Next is table movement. As you can see, this area down here is called the table. To move it in the X direction, there are knobs here and over on the other side over there that move the table like that. Now for the Y direction, there is this knob here, which moves the table forward and backwards, like this. Now to move this whole table up and down, there's what's called the knee here. You can use it to lower and raise the table. To keep track of all this precise table movement, there is what's called a digital readout, or a DRO. This digital readout has an on and off switch on the back, and it can display very precisely where the table is. So if I start to move this, and the other one, and you can do things like 0. So if I want to set this as my 0, that's how you do that. And if you want to enter in a value, you hit the X that you want to enter in a value, then you hit enter, and it sets that as your value. After finishing step 6, we need to move on to step 7, which is very essential. That is, how to change the bit. Now the reason I changed the camera angle is because we need a side of the whole head. To remove the bit, there is what's called the drawbar up here, which I'll show you a little bit closer. But you need to engage the spindle brake and pull and twist the drawbar, because it is engaging with the screw on the bottom of the collet that is holding this bit. And with some careful nudging, the collet and bit will fall out. Now, what kind of bits are these? Well, we're getting ahead of ourselves. We'll talk about that later. What is holding it here is called a collet, and it has a threaded edge in the back, which interacts with the drawbar that you see the end of up here, which actually is in the bottom of here also. Alright, now we're on to step 8. What are these bits? Well, I will pass 2 of them around after this presentation is finished, but for right now, these are called end mills. This one is a 4-fluted end mill, and you can tell because there are 4 channels for the chips, or like things that come off of the work that you're cutting, to go through to get out of the way of the bit. There is also, if we go over here to where they are all kept, in these 2 boxes up here, there are 4 fluted versions, which I showed you, and then there are 2 fluted versions, like this one. Now, we move on to step 9, the quill. The quill is actually what is holding the spindle. There is a spindle lock here that stops the quill from moving up and down, and then there's a handle up here which lowers and raises it depending on how far you have the stop set. The stop prevents it from going down past a certain point. In this case I have it set at about 1.5 inches, so the quill can only drop 1.5 inches down, say if I wanted to make a consistent height for a bunch of holes that I'm drilling. As I mentioned before, there's the lock here, and that does not only work in the top position, but it works in any position that you would like. Now we move on to my favorite feature of the mill. It's what's called the power quill feed. Now this, I haven't found a super useful project to use it on, but it's still a very fun technique to use. Now before you do any of the cutting, you'll have to use this engage quill feed. As you can see, there's a little plate there, and then you can select the speed in which the quill lowers with this knob here between, I think, 6, 1.5, and 3. I will now demonstrate. So now the motor needs to be on when I engage this, and it is now engaged. Now you can see that this is spinning, indicating that it is already in a direction. We can change the direction by either pushing in or pulling out this knob. And we have it set to 6, which is a very fast feed rate, but this is a very thin or light material. So for the quill to go down, you want to push this in, and then make sure the lock is disengaged, and pull this out. And there it goes. And once it hits that stop, bam, it stops. And then you can pull it out, hit the lock, and turn off the machine. So, in conclusion, that is the basic operation of the mill. You can do anything from milling slots to drilling holes to making things perfectly flat. I hope this helps your understanding on how to use another great machine in the lab. See you next time.